Good morning, fellow teachers and students, and good morning, class.
Good morning, Mr. Sarang.
All right, you may sit down. All right, in the lesson we'll go through and then have a look at another form of energy, and that is potential energy. All right, before we go through that, I'd like somebody to give us the definition of potential energy. Choose.
Potential energy is the energy a body has because of its condition or position.
Okay, well done. Now, this energy is a form of energy that a body has to have by virtue of its position. All right. All right. We will now go on to have a look at the definition, and then I will ask somebody to come up and you will demonstrate to us what using a stone, and then probably you can give us your explanation, and based on that fact we will move on and then study more on potential energy. All right, quickly have the definition. Okay, I will now ask somebody to come up. Rachel. Okay, Rachel will come and then she will tell us the differences or what she can feel from these two messes, right? I have two messes. One is this, and then there is another one. All right, she's going to tell us or describe anything that's about these two messes, and then probably she can just drop that from a certain point. And then she will give us the explanation of which one of these will produce the highest amount of energy. And then giving that, she can also explain exactly, observe from this experiment what she, let's say, what was the behavior of these two when they reach the ground level, and that is the floor. Okay, so I will now ask Rachel to come up. You can compare these two and then give us the explanation of that, and then you drop that.
To compare these two weights, the stone is much lighter than the weight. I think it's a 50-gram weight. Yeah, the stone is lighter than it. And if you drop it from a point, just to the floor. If you drop the weight to the floor, it remains in one position. And if you drop the stone to the floor, it bounces and moves its position. To conclude, I could say that the weight has a faster rate of acceleration due to gravity because it's heavier than the lighter stone.
All right, I'm quite sure you have observed what she did, and from that explanation, looking at the this energy, you find that it depends, or the fact of this is that it will give you a reference of the ground level. Okay, that is a reference level. So meaning that at ground level, the potential energy will be 0. Why? Because it has not been taken to a certain position. And then it also depends on the initial and the final position of the fall. All right, if it is taken to a height, you must consider the initial and the final position. Now in this case, it does not vary, or let's say that variation cannot depend on the path in which it travels. It can also slide down, and still that is the potential energy. All right, so I will go through quickly, and then probably towards the end of this, what I gave you, I will give you some questions. All right, in this case, if you want to find the velocity of that object, all right, you start off from this potential energy, and then you can calculate to find out. All right, why? Because when there is a conversion of energy, you have this energy which will change into this. So placing in all of this formula, which is mgh equals to half v square, and then you come up with this. All right, and finally, if you want to find the velocity, and then v equals to square root of 2 gh. Okay. All right, I will give you the information given there is, since the acceleration due to gravity will vary with the height, and then also the position on the earth. But then you find that the gravitational potential energy shows a similar variation. If you have it, or if you take it to a certain height, all right, it depends. The force of gravity is also constant and does not change. But then it depends on the height, okay, from the surface of the earth. All right. This variation will depend on the two facts here. Okay, one is that in determining the potential energy of the object or the mass, all right, the reference level must be considered, and that is the ground level. Okay, moving on to fact 2. It does not depend on the path, but it depends on the initial and the final position. Okay, given one example is, for example, if I have to draw this one, you find that the path of the travel is in a manner like a projectile, okay? But if I have to also drop, so that means it does not depend on the path it takes, whether it is moving like a projectile or when it falls straight or moving sideways, it still does not matter. It will still have the same potential energy from each of those two positions, the initial and the final. Finished now? Have you finished? Okay. I will now give you the activity questions. All right, this is activity question number 1. There are 3 questions, and question number 3 has 2 parts to it. All right, quickly copy question 1. if you have any difficulties with those questions, please raise your hands so that your teacher will help you. Okay, there is a 2 kilogram hammer that is lifted from a height of 50 meters to 60 meters above the ground. All right, that is question 1. Question 2. Right here is question 2. All right, for question number 2 is you were given only the amount of work that is done by a 5 kilogram body. And at what height will that amount of work be done? Okay, that is question number 5. Rather, question number 2. And the third question is at what height will a body of 20 kilogram mass do no work? Okay, Samuel, you do question number 2. Okay, you'll do question 1. Samuel. You go and do question number 3. Question 3. Okay, question 1, question 2, question 3. Question number 4. Give you very shortly. Okay, here is question number 4. Correct. Malcolm, question number 4, A and B. Okay. What do you know about the weight? Weight is equals to? Okay, there is acceleration due to gravity. When you're given weight, you can remember from last lesson in force and pressure. So you know the force of gravity, the weight. No, this is in kilograms. You have to find the weight in newtons. Okay, how do you do that? Yeah. The answer is? Okay.
Times the distance, 100 minus 100 divided by 50, that's 2 meters.
Okay. So if you were using that formula, P equals to mgh.
Acceleration.
No. G is the acceleration,
M is the mass.
m is the mass, and h is the height. Well, question number 2. You finish your working out. Let me see. Okay. All right. Okay. That's right. All right, good. One student has done the answers correctly, or the questions. Question number 1, where you are. All right. I am quite sure some of you may have used those information to work out the problems. I will call upon the first person to come up and then probably do your calculation on the board, and then you can explain and go back, and then we'll have the second person to come up. Okay, so for question number 1, Samuel. All right, Samuel, to question number 1, and Diane, you get ready. Okay, clean this one first.
Using the formula for potential energy, you get the 2 kilograms of the weight times 10. That's from gravitational acceleration. The height 60 meters minus 50, and you get 200 joules of energy, potential energy.
All right, hands up those students who got that answer. Okay, good. That is correct for question number 1. Moving on to question 2.
Since we know the potential energy is equal to mgh, which is the mass times the gravitational force, which is 10, you got 100 equals 50h, and height is equal to 2 meters.
Okay, again, for question number 2, if we have 2 meters, hands up if we have 2 meters. Okay, that is correct. 2 meters is the answer to question number 2. All right, we now have the third person to come up, so you're working out for question 3. Or you can answer from, okay, come. You can use calculation to explain this question.
Potential energy equals to mass times gravitational force times height. Potential energy equals 0. Mass times gravitational force, which is equals to 200.
0 divided by 200 equals to 0. It's the height.
Okay, very good explanation. You can also use mathematical calculation to come up with or find whether work is done or no work is done. But looking at this, when you have to take, because of its position for potential energy, if you take it to a certain height, it will do work. But otherwise, no work will be done at ground level. Okay, so at ground level, if you have ground level, that is correct. Okay, the height will be 0 at this point. And finally, moving on to question number 4, there are 2 parts to it. Malcolm can come up, write your 2 answers on the board.
For the first one, potential energy equals basically the energy. So it's multiplied 1 times 10 times 20, I got 200, and because P is equal to K, I got 200.
Okay. Our answers for this will be 200 joule, and okay, this one will be also 200. Now, before I summarize, I'll go through and explain to you exactly how we can okay, let's say, for example, if we decide to throw a stone, all right, the stone will have to take this part, and then from there, it will have to come back down. Once you throw that, at this height, it will have, okay, potential energy, because it does not have any velocity. Velocity is 0 at this point. Once it loses all its velocity, it will now turn and then make its way down to the at ground level. So at this point, we can simply say that it has a maximum amount of potential energy. All right. When it comes back down, probably in the middle we may have, let's say if it is at here, it was 200 joule. Okay, in that case, if it is halfway here, we will say that K PE is now 100 and KE is 100. Okay, it will have to change. Okay, at this point, probably may have less of, let's say, 50 joule, and then this one will be 150 KE. Okay, it drops until at this point at ground level, most of this potential energy will be changed into kinetic energy. All right. Why? Because there are 2 factors. One is the height, and also the level in which, or the position in which it is taken to. All right. So you can use that to calculate the potential energy. Right, looking at the velocity, as I've said, if you want to calculate the velocity at this point, you can consider this one. All right, that is 1,000 or 100 joule, and then that will give you v squared. And then using this, you can now calculate the amount, or let's say the velocity at this height. Okay, you can also calculate the velocity at different points on the path. Okay, so that is how you can find the potential energy and also velocity. All right, so in our next lesson, we will have a look at the energy conversions in a pendulum. Okay, what happens, or what is the path taken by the pendulum, and how you can calculate the velocity and different amount of energy at different points of that oscillation. All right, so these are the answers to our. Okay, the question 2 will be 2 meters and not 20 meters. So those are the questions, rather the answers to our activity questions. All right, so that brings us to the end of our lesson. Our key phrase would be potential energy. Good morning, pilot teachers and students, and good morning, class. All right, thank you. You may sit down.